Hi, everyone. My name is Victor Cabreira. I'm a professor and extension dairy specialist with the University of Wisconsin-Madison in the Department of Animal and Dairy Sciences. Very excited today to share some work we are doing in our lab, and in this case specifically about the economic value of nutritional grouping on dairy farms. So let's get to it. Nutritional grouping can be beneficial by many aspects in dairy farms. We are very convinced of this indeed. It will decrease feed costs, it will increase feed efficiency, it will increase productivity, even though we don't have actual data. We need more research to quantify that increase in productivity. It will improve the herd health. And another important thing nowadays, and every time more important, it will decrease the emissions or the impact to the environment. Throughout the presentation, we are going to use indistinctly TMR, which is total mixed ration or diets. And in this case, calling one TMR means we are giving one diet for all lactating cows, which is very common in many farms nowadays. If we do that, we will increase the overconditioned cows, and it will increase the nutrient excretion issues on dairy farms. Indeed, one TMR, one diet, is a standard in many farms, as I just mentioned. And a few years back, we did a survey research in Wisconsin and Michigan, and we found out that about 58% of the farms will use just one diet, one TMR, in all lactating dairy cows on the farm. So if we do one TMR formulation, likely the diet will be more in tune to the high producing cows. And therefore there would be a lot of overfeeding in the low producing cows. If we do groups, and if we provide different TMR, different diets to those groups, the diets for sure are gonna be more precise. We will have an improved feed efficiency on the overall herd, and that will reflect in greater milk income or feed costs, and at the end, greater profitability on the farm. Nutritional grouping also has been cited in many studies to increase the body condition and improve the health condition of the cows overall. If we do more precise diets, obviously we will improve the productivity, and that will reflect also on the profitability and the income or feed costs. Doing nutritional groups will decrease, the idea is decrease the variation between or inside those groups. The cows that are inside the group will have more alike requirements in the density of the diets. And we will increase the intergroup variation. If we have two groups, for example, the variation inside the group will be less, but the variation among the groups will be greater. And we will decrease the competition at the feed bank for sure. So as you can see, all this is literature in not too far away years indicating that grouping is a good alternative to improve feed efficiency in the whole herd. But we found out there was a need for continued assessment of these nutritional groupings, and most importantly, the economic efficiency of doing so. So we work on that, and we published in 2016 this paper in the Journal of Dairy Science about the economic impact of nutritional grouping in dairy herds. The first part of this presentation is going to be heavily concentrated on this publication. And also we published another paper that was more like a review paper, where we actually summarize all the important previous studies about nutritional grouping. So here's what we did on that 2016 paper. We developed a model, and we used the model to quantify the nutritional grouping value. So it's a daily stochastic Monte Carlo next event model for those who are interested in the modeling part. But the whole idea is that we were able to follow a specific cow level simulation at the daily step. So every single day, every single cow was being simulated, and we could simulate on the herd doing groups or not doing groups, nutritional groupings, I mean, changing the diets or not for different groups. And as you can see here, the stochastic events being simulated were pregnancy, culling, death, abortion, dry off, parturition, and many others, trying to represent what happens on a dairy herd, and within that, use as a model for a research in the computer. So to give you a little more detail, I'm not going to go in all the text here, but the bottom line, this is the framework of the modeling. We have a initialization part in which we enter all the data. We define the herd or herds we use to do the analysis. And then based on that, we have a simulation and a daily step, and we impose or not groups according to different criteria, how we group the animals and how we will formulate diets for those animals that are being grouped. So more specifically on the case of the diet groups or the different TMRs we tested from 1 up to 4 actually TMRs. We tested 5, but it didn't make too much of a change at the end. And the idea was to have a solid and systematic criteria, which cows would go to which group, and how that will interact with the actual daily and real situation on the farm. Some cows will reach the situation that they are dry cows and they will be parturing, having calves throughout the time. And therefore, all that need to be accounted within the systematic pens or facilities that the farms would have. A few more details about the simulation modeling. We use cow level requirements, but we emphasize on the net energy for lactation as an important nutritional factor, and the metabolizable protein, basically. And then regarding the body condition score, we actually follow this every single cow, every single day, and in a scale from 1 to 5. But indeed, when the body condition score was lower than 2, or was going to be lower than 2, we decreased the milk to avoid much lower than that body condition score. And similarly, if the body condition score was going to be greater than 4.5, we decreased the dry matter intake to not allow such a high body condition score. So somehow try to limit those changes in the body condition score, but still checking what's going to happen with the body condition score when we do groups and when we not do groups on the herds. And then we projected at the cow level, the milk, fat, protein, body weight, and body condition score, as I said before, every single day of the simulation for a long period of time, for sure. And so we did nutritional grouping, and the nutritional grouping included actually only animals after the post-fresh period, after 21 days. Those fresh cows are different, and they would be in their own group, if we say so, for example. And we did a monthly regrouping, thinking that farmers would be able to do that, more realistic situation. And we used the clustering to group the animals. And clustering means basically we group the animals that were more alike in the requirements of net energy of lactation and metabolizable protein. And in this case, for analysis purposes, we assume the size of the groups will be the same. So we will divide all the available cows by the number of groups. Again, we did the monthly regroups and based on energy, net energy of lactation and metabolizable protein. And the same nutrients were used to the diet formulation. And in the case of the energy, we use the average of the groups that will end up in a group. And for the metabolizable protein, we use the average plus one standard deviation. And we use economic parameters that represent the situation in Wisconsin and in commercial dairy farms in the US in general. This could be changed, but at the end, this will apply whether they are being grouped or not. So we think the major change, the major difference, it is based on the grouping strategy, not on the prices themselves. Indeed, we did some sensitivity analysis. You will see the results in just a moment. So we tested this with real data of 5 different farms, the smallest one, 331 cows, and the largest one, close to 1,500 cows. And you have here some statistics. I'm not gonna go through those. What was the milk production on average, percentage of cows in first lactation, et cetera, the pregnancy rate. You can see in a decent level, not too high, not too low either, et cetera, et cetera. So all this information is important to represent more realistically each one of these herds. So if we pick one of the herds that had about 600 lactating cows out from the 5 I showed before, this is what we observed, and this is only for illustration purposes because this would be very similar in many farms. Here's the point. Depending on the stage of the lactation, depending on the production level, and many other things, the requirement net energy of lactation, and in this case, megacals per kilo of dry matter, density-wise, which largely change from close to 2.1 to less than 1.3 megacals per kilo of dry matter on all these about 600 cows. If we formulate one diet based on energy for all these cows, probably the diet would be about here 165 megacals per kilo of dry matter, let's say. So almost 500 of the 600 animals will be overfed. It is true that there would be about 100 cows that would be underfed, right? Every time we do a group, we do a compromise. The ideal situation would be precise feeding, and we feed what each cow requires density-wise. But we need to do a compromise. But if we have a large variation and a large number of animals, and we give only one diet, it's grossly underrepresented to the whole population. And so there will be a large number of both overfed and underfed, but likely more overfed than underfed. And so one solution for this is if we do groups, each one of the groups, still there will be some variation from what is required, but they will be closer to the requirements. And here's the example. And this again is with the same farm, with the same about 600 animals. And you can see here, in the thin line here, what's gonna happen if it would be only one TMR. 2 TMRs would be if it is the thicker curve here in a gray, and if it is 3 diets, would be the darker, thicker 3 component of groups of animals. And as I said before, even though they will not be perfect yet, the difference between the provided energy minus the required in megacals per kilo of dry matter, which would be the 0 here, the 0 line, would be much better if we do 3 groups than if we do 1 group. Here, the lower number is better because there is less difference between the provided and the required. And this is only for demonstration purposes. Obviously, there are much more components and factors that we need to encounter and use into the analysis. But this is just to show you what the bottom line, what what the motivation behind is. Actually, when we did the simulation and we reached what's called some level of equilibrium, a steady state of the herd, we can test 2 diets versus 1, 3 versus 1, or 4 versus 1 diet or TMRs. And if we put all together, if we look for a moment to the top numbers on top here, mean how much more money we would expect by doing 2 diets, 3 diets, or 4 diets compared to only 1. For example, we are gaining $39 with 2 diets, 44 with 3 diets, and about $47 for 4 diets. Just to note here that the 4 diets was only done in the largest herd, because it seems to be that with smaller size herds would not be too much of a difference or too much of a need to do so. So there is a good gain, and actually we have the components of the gains here. One important factor was the RUP within the protein side of the diet. There was a big savings by doing more diets. Extra milk being produced, another big value here. Even though, as you can see here, there were also negative values. The net energy of lactation and the RDP were negative in all the cases in different levels. But the point is, those would be needed a little more depending on the situations and the conditions in the farm we are simulating. Bottom line though, overall, we will have a highly positive value. This is in dollars per cow per year by doing more groups compared to not doing groups or just giving one diet to all the lactating cows. And actually, if we compare this with previous data, earlier data, the numbers are not too far away what were reported by Williams and Aldenat in 1992, for example. As you can see here, between $21 and $40 when they compared 3 diets versus 2 diets. And also St. Pierre and Tren in 1999, they found between $44 and $77 with 2 diets or 3 diets compared to 1 diet. So we are basically in a, I would say, in a comparable situation of what has been found before. And the important thing I think we show here is we corroborate what has been done, but we have much more factors included. And as you can see in a moment, there are much more implications of what we simulated. The detail of the simulation was done in much more detail. So just to conclude briefly here, nutritional grouping will increase the income or feed costs and will increase the profitability. That's clear. And this will obviously will depend on the farm conditions and the market conditions. Therefore, having a simulation model in which we can change the conditions is very important in our opinion. And if somebody would ask what's the optimal number of nutritional groups, I would say 3 would be the number I would recommend in most of the situations. Rather, if the herds are very large, more than 1,000, more than 2,000 animals, maybe 4 or even more TMRs would be appropriate. It will depend also on the conditions of the farm, like the facilities, the number of pens. So it is a compromise somehow, but these are like a general guidelines that could be used on that. Okay, so just to give you a little more detail on the results, you can see here doing 1, 2, 3, or 4 diets, what would be the level of the diet regarding to energy, RDP, and RUP. As you can see, if we do, for example, only 1 diet, the energy would be 1.5. If we do 2 diets, actually one of the diets would be higher than the 1.5 and the other diet would be much lower than the 1.5. But if we average these 2, very likely it's gonna be lower than the 1.5. And the same would be applied to the RDP and RUP. And if we do 3 or 4 diets, like in this case, we will have likely one of the diets much higher than the one diet, but the other 2 lower than the one diet. But the overall average of all the energy being provided to the animals will be lower, which is where we save the money. And bottom line as well, it would be the cows will receive closer to what they require, and therefore they would be better off in body weight, body condition score, they would produce more, and overall we will improve the health of the herd. So going back a little bit to early on work of McGilliard in 1983, for example, that's what they recommended of energy, and they actually started this nutritional grouping work. And even though they didn't have the level of simulation we are presenting here, the conclusions were somehow very similar. One of the surprises we had as we were working on this is the fact that this has been reported in the literature for quite a while, but it seems to be that the industry has resisted to do more groups. And we believe in part is because it's easy to do one TMR for all the animals or do only few TMRs. It's more practical, easier from the management standpoint of view. There may be other limiting factors that we're going to discuss in a moment. And we think it's important to revisit this concept and try to engage more farmers on this idea. And not only from the standpoint of view of the economics, that's important, but from the environmental standpoint of view, we know this is coming every time stronger and stronger, more stringent restrictions on the emissions of the farm. So there's going to be a push to be more efficient. And one way is doing more nutritional groups. So going more into the details of the results, you can see here 3 curves regarding on top here, the net energy of lactation, and on the bottom regarding to the metabolizable protein on the left y-axis, and the net energy of lactations on the right y-axis. The point here, it's very clear. If we look for a moment to the top curves, you can see the green one is if we do 3 TMRs, 3 diets. The blue one is with 2 TMRs, and the very thin gray line is from 1 TMR. The point is, if we do 1 TMR beyond the post-fresh period, the diet that the cow will receive will be exactly the same almost until the end of the lactation. And so that's very different if we do 2 or 3 MRs. And like in this case, let's take a look to the 3 MRs. You can see that the curve of the green thick curve here follows what we would expect from a lactation curve, in which the cow will require more nutrients, more energy in this case, early in lactation. Throughout the peak, it will start decreasing, and actually in late lactation will require much less of what they are receiving. So early in lactation, if we do 1 diet, they receive much less than what they need, and late in lactation, they receive much more of what they need. So that's a problem, and one way to solve is to do more groups, simply and plain. So cows are fed closer to the requirements with nutritional grouping, and more in early and less in late lactation. So just like a summary of the graph we saw before. So the net energy of lactation would be more efficiently given according to the days in milk and the productivity of the animals as well. The curve is in general for all the animals in 1 lactation, for example. But if we will look this at the cow level, this would be even more precise. And the benefit it would be greater by doing those groups than not doing the groups. And obviously, as I mentioned before, and we have already seen, there would be less overconditioned cows and problems of late lactation, overcondition, and metabolic problems in the next lactation for animals that have been overfed late in lactation. Indeed, here is the part I would like to discuss. I mentioned the model was able, like no other before, to actually keep up with the body weight and the body condition score of every single animal every single time, whether they do one diet or 3 diets, for example. And here the one TMR is actually the dark blue distribution, and the clear one is the 3 TMRs. You can see there is no much difference between the body weight distribution of the cows, whether we do 1 diet or 3 diets. We can say stable body weight with the groups, and this has been already similarly reported in other research by other research groups. But now if we look at the body condition score, actually if we do 1 TMR, 1 diet, you can see very high concentration or very low body condition score animals, and the same on the other extreme, very high concentration of animals with very high body condition score, very different than the distribution of the 3 TMRs, in which we have more alike bell-shaped normal distribution, as we would expect, as we hope. If you can see here, the mode is 3.25 of this distribution of the 3 TMRs, and from the 1 TMR is very thick tail, and 2.75 of the mode. Plain and simple, much more over condition and under condition with 1 diet compared with 3 diets. So nutritional grouping appears to ensure that energy is better distributed and cows are healthier. So if we move on that to the nitrogen use efficiency, more nitrogen is captured in the milk of the cows with more diets. And actually we quantify that to be 2.7% higher in 3 TMRs compared with 1 TMR. 2.7 may not seem a large number, but we all know that every percentage point we can make on use efficiency of nitrogen is a big deal. And obviously we would expect lower nitrogen emissions. This has been already reported and expected, obviously. And actually here is what we did regarding to milk nitrogen produced versus the feed nitrogen consumed. So this is feed efficiency, basically. We know this number in normal herds will go between 25% to 30%, so it's very low. So that's what I was saying. Every percentage point of gain we make, it's a big deal. And here are the different herds that we studied. You can see here that as we increase the number of TMRs or diets or groups, we will increase the efficiency of the use of nitrogen on the diets. Okay, I mentioned we did some sensitivity analysis. The base scenarios on top here, what we encountered as economic gains by 2 TMRs, 3 or 4 TMRs. But we did some scenarios like worst economic scenario or the best economic scenario, with very best would be very best, good price of milk and very low prices of feeds, for example. Point B, it will change relatively little the benefits. With the best condition scenarios, we will have better gains, and with the worst, a little lower, but not much lower indeed. The gains will hold very well regardless of the market scenarios indeed. Now, we did another scenario here in which we expect a milk loss. One of the concerns of the farmers of not doing nutritional grouping may be the fact that cows need a time to actually get used to the new group they are assigned. There is a social hierarchy, and that's in debate as well. I think that requires more research yet to point that. But based on the literature we found, it would be reasonable. Indeed, it's a very conservative and high number to expect 5 days of loss of 1.8 kilos every day until they reach the normal level, every single cow that's being moved. If that's the case, the value of the 2, 3, or 4 TMRs will decrease, but still will be a good value by doing the nutritional grouping. The other scenario we tested was first lactation animals to be one specific group. Many farms do that and probably will remain or would like to keep doing that. So if we do that, basically the situation is that what's gonna happen is basically the first lactation would be a separate group, and our value of doing different diets will decrease because we cannot use those as a group criteria as we are doing with the other animals, but it still would be of a good value, as you saw there. So higher gains with best economic conditions, even at worse economic conditions, though that's important, gains are substantial. And even under assumed losses of regrouping, there would be substantial gains, which is important to point out. Separated first lactation cows, as we saw before, will decrease a little bit the income or feed cost, but it still will hold up a good value. Regarding regrouping losses, that may be one of the most important factors that prevents farmers to do the groups. Even if we use very large amounts, the largest we found in the literature was 2 kilos during 7 days, it will still hold its value. Now, one thing additionally I will point about regrouping losses is the fact that new research is showing that larger groups, as herds grow in size, will have cows more difficult to recognize and have this hierarchy within the groups. Indeed, it seems to be that above 60 cows in a pen, maybe the detrimental effect of moving cows between pens is negligible. So maybe this would be something we need to revisit and may not be a constraint for doing groups on the cows. So in conclusion, I would like to point out that nutritional grouping has an economic value and should be promoted. That's our conclusion in general. The difference, as we saw before, in general would be $39 for 2 TMRs, 46 for 3 TMRs, and 47 for 4 TMRs overall. Point B here is our recommendation 3 or 4 groups at the most. There is a law of diminishing returns. If we try to do too many groups, maybe it's not worth it because our gain is very small compared to the resources and effort required to do more groups. And the gains in our case were explained in our factors by more milk and less cost of RUP. And potential losses due to regrouping would have a deleterious economic impact, but it would be much lower to disregard the nutritional grouping as an important factor to improve profitability, efficiency, and decrease of environmental impacts. So one thing I wanted to share with you is the fact that a simplified version of that simulation model, it is actually online available, freely and openly available to everyone. And that's on my website, that is dairymgt.info. If you just Google Dairy Management Wisconsin, this would be the first place that Google will show you potentially. But anyway, it's very simple to remember, Dairy MGT from management, mgt.info. And then there is a section of tools. Indeed, there are more than 40 different tools, and there may be other tools you would be interested to look at. One of those is the grouping strategies for feeding lactating dairy cattle, which is directly related of what we have just discussed. Here is a tool, a screenshot. And in this tool, very simple, you define what would be the price of protein and energy. In this case, we work with crude protein rather than metabolizable protein. So the idea, the user can enter corn and soybean meal prices, for example, in order to determine the price of protein and energy, or can enter directly those values into the tool, the same as the milk price. But the important data set actually is cow-specific data that's needed for the analysis. And that's basically cow ID, lactation, days in milk, production level, fat, and body weight if available, only if available. Once the data is entered, the tool will count the number of cows. For example, in this case, there are 470 in the same sample farm that appears by default in the tool. And based on that, the user can go through very simple questions to group the cows or not, and find out what's the value of grouping those cows, okay? And actually there are situations in which the farmer is doing some grouping already, and other cases they are not doing any grouping with the lactating cows. If they don't do any group, how many they can do, what's the current diet for the one group they do, what would be the group sizes, and then the tool will provide what's the added cost and benefits. And very similarly, if the farm does some grouping, the tool can propose to do more groups or different criteria, more efficient way to do the groups. And at the end, it will show as well the added costs and benefits. And the important thing is likely the benefits are gonna be greater than the costs. So it's just a series of questions, very simple. How many groups do you have? How many you can handle? What are the size of the groups? What's the diet currently? And based on that, the tool will return you, after some calculations internally, what is the total value of your grouping for all the cows? What would be if you would do cluster, which we think is the most efficient way to group the cows. But in other situations, farmers may prefer to do group the cows by daily milk, or by fat corrected milk, or dairy merit, which is a combination of fat corrected milk and body weight of the animals. And this data will also be displayed in a nice table like this here, suggesting what would be the number of cows in each one of the groups, what would be the diet of each one of these groups, and indeed, it will provide the user which cows would belong to each one of the groups. Our suggestion is someone who wants to use this, the fact that they can do this every month, for example, to regroup the animals and change the diets according to the calculations here. So if we use the default data set with 470 cows there, just for illustration purposes, and we do 3 groups of 100, 100, 270, and we compare that with doing no groups or only one diet, and we added cost of 1,000 additional by doing the groups and the extra mixing of the feed and management, etc. That will give us at the end $338 more per cow per year. And I mean, this would need to be done more fine with the situation of the farm, but the bottom line is that the tool is available and it's a good motivation to start thinking and continue the idea of doing the groups on the farms. Now, I would like to continue in the last part of the presentation and talk about how we want to operationalize or make it available this in a more direct way to dairy farms. We have a very nice project in Wisconsin that I have the privilege of be leading, and it's called the Dairy Brain Project. And I'm gonna give you a little more details about that, but I just wanna mention here, it's a heavily interdisciplinary work with many other animal and dairy scientists, many computer scientists, and also data scientists, students, postdocs, many faculty, etc., which is very exciting. And it has its own web page as well, dairybrain.edu. So we count with very progressive and very kind farmers who are providing us data to actually demonstrate the concept we are trying to do here. And the main idea basically of this Dairy Brain is to use all the data available on the farm by integrating them. Our main motivation is the fact that this is the way we see how the data is being handled on farms, or how is the dairy data ecosystem in farms. There are many silos of separated independent data streams. Like, for example, on one side we have the feed, and on another side we have the management data and the milking parlor sensor in separate parts. And when we try to use data from different sources, it's very difficult. And even if we do it, it's one-time deal. The idea is all these data sources should be connected as they are being generated. And using like a funnel idea, what we are trying to do at the moment is create this agricultural data hub that will bring all the data together, standardize the data, homogenize the data, and actually connect all the data as the data are being generated. And this data can be fed to decision support tools like the nutritional grouping I discussed before, and make this available to the farm in a constant base, rather than the farmer or the nutritionist collecting the data, putting the data in the right format, feed into the tool, and then collected the results. Everything should be automatically done following this conceptual framework. So we need to integrate data. In this case, for the nutritional grouping, we have data, or we need data from the feeding, we need data from the milking parlor potentially, and the data from the processor as well, the bulk tank, what has been produced every single day and shipped, for example, out of the farm. Within the Dairy Brain project, we want to create these different type of tools, whether they are descriptive, just to show some benchmarks and show some dashboards, or predictive to see what's going to happen in the future, or prescriptive. In this case, this nutritional grouping would be categorized more on this area of prescriptive, in which we try to suggest some management options to the farmer. So we need to predict what's the best situation and what they should do after they follow our recommendations. So the last part of this presentation, I'm gonna concentrate on the work of a former student on my lab, Jorge Barrientos, that has been, and this is, by the way, published in the Journal of Dairy Science last year. And the idea is systematize and automatize the decision-making process of doing these groups by collecting data, integrating the data, and making all the analysis as much as possible. One thing we found that would be very useful as well, all these processes decrease errors that currently happen in the grouping. Farmers are doing groups anyway, whether they change the diets or not, because they need to move cows to different pens. But there seems to be a lot of errors on these grouping strategies, and we could help with better data to do this management. And so the whole idea is facilitate the implementation of a continuous, I think this is a keyword, continuous nutritional grouping on the farm. And then at the end, we will provide more accurate diets and will be more efficient in the dairy farm overall. So the concept is very simple. This is what happens on the farm, same or not reformulate diets. We do the nutritional groups, we separate cows in different pens, and we have different and better diets to each one of the groups. But one important point I wanna mention here is the fact that we need to do this within the workflow and the practices that the farmer already does on the farm. If we try to change too much what happens on the farm, it's very likely they will not adopt our recommendations. So the first thing we did is try to find out in one specific farm what they do, and we try to connect what they do our system. So basically Monday PM every week, the farmer print a list of animals and by hand actually move the cows in different pens that need to be moved. At night, Mondays, the crew of employees actually using some sorting gates, electronic sorting gates, with the help of sorting gates, will move cows, and Tuesday AM, they confirm the cows will be in the pens. But we know this is a large farm with thousands of cows, and some cows will end up in pens that they were not assigned they would be. And so as you may understand, it would be difficult to move them once they end up on this. But anyway, that's what they do between Monday and Tuesday AM. And this is actually what they try to do and what ends up. In this farm, which is a large farm, there are 14 pens from 1 to 14 here that are being provided 9 diets. So that would be good from the standpoint of view of nutritional grouping, because there are different diets for different pens. But you will see they don't change too much. But even though I would say this is a better than average farm doing this, okay? But one thing I want to point out is there are lots of misclassified, as I was saying. For example, in this peak group, which are pen 8, 9, and 10, which are the peak of the multiparous cows, you see here there are 2 blocks. This is primiparous and this is multiparous. There should only be here multiparous cows on the peak. So actually there are a lot of cows here. You can see the extreme here with almost 500, 400 days in milk, still in the peak of lactation, that they don't belong. They will be receiving a hot diet, 1.77 megacal per kilo, and likely they don't need or want to consume that hot diet or high density diet at that point. Same happened with the primiparous peak, for example. The other important point, all these peak lactation, primiparous or multiparous, will receive the exact same diet, right? And there are other situations where there are 2 groups that receive the same diet as well, and there are differences between those animals. I mean, one way to see the difference is the distribution in these box plots. This is the maximum, the minimum of days in milk, and they will receive the same exact diet. So the idea is to narrow down these distributions and actually provide a diet that is closer to their needs, okay? So if we would work only on the peak lactations, our gains would be much higher, but we understand here in this analysis, we need to work with the whole herd and actually see the feedback, because if we move a cow from the peak, they will go to the late lactation maybe, or the other way around. And therefore, it is heavily integrated among all the pens and all the cows. The other thing I would like to point out here is diets are reformulated 3 or 4 times a year only. That means that every single one of these diets are being done once based on prices of the feeds, and they will remain there regardless of which cows end up on those groups after the grouping every week. And diets obviously are not based on requirements of the animals. So this is what happens. If for a moment we ignore the colors here, every single point are the cows in the peak of the multiparous cows. In this big group, there are 480 cows, and actually they are divided in 3 groups. But the farmer and the manager don't care. They don't care where one cow will go to group 1 or group 3 of the peak, because at the end they will receive the exact same diet. And that exact same diet would be the dark solid point here regarding energy and metabolizable protein. That's the diet that all these cows will receive at the end, regardless of what pen they are. And so there will be some cows that will be heavily overfed, as we have seen before. And there would be a few cows that are underfed. But if we group this, and actually we make an effort to put the top cows in one pen, the middle cows in another pen, and the lower cows in another pen, actually we would have 3 diets, which would be the open circles here for each one of the groups at the same level. Basically, our diet of the top cows would be a little higher than what it is. So these cows in red would be better fed with a hotter and more densely diet formulated. But we will have the green and the blue that will have a much lower density diet. Still, the cows would be very well fed, but we will be saving a lot of nutrients on those diets. In order to do so, actually what Jorge did is connected herd management data, feed management data, and diet formulation data. It is prepared the system to have other data sources if we have more precision as well on this. In this case, the connection of the data was on pen ID and date. And so every single time the data is coming from these different sources, they go to a central place, and then the calculations are made to see which cows belong to each group. And this is what the analysis end up. We have 14 pens. So the goal would be for each one of those pens, without changing anything on that, to have one diet. And you can see here, every single diet would be much better formulated to the situation of those cows. The other important thing is that we will have no or very little misclassified cows, because they are we have a better protocol or more systematic protocol to assign cows. You see the distributions overall are more narrow, and so we have better homogeneity within each one of the groups to provide a diet that would be closer to the requirements in each single situation. Now, in order to make an analysis closer to what they do, the diets were not reformulated weekly. We use historical data, and we did a diet for each one of these groups that will remain for the 3 or 4 months the same as they are currently doing. But if we would reformulate every week, the gains would be even greater. But having the reallocation every week, as they do in this farm, is also a good opportunity to better allocate the cows and provide a better diet to each one of the cows. So then we do an economic analysis, and actually we compare the number of cows, obviously the current practice, what they do, and what's the proposed practice, but probably more important, the diet costs. What's the current practice and what's the proposed practice? And you can see here, as I said before, in the peak of the primiparous or peak of the multiparous cows, there is a big gains to be made, at least in 2 out of the 3 groups, because we are giving much better precise diet to those groups. But also I want to point out that in this 14 pen, the diet being provided in the current practice, according to our calculation, was much lower than what they would need. And actually that was a big negative value in our calculations, but we needed to include in order to make a whole assessment of all the cows on the herd. And if we even include in that, the gain is or was $31 per cow per year, which is not insignificant. This gain would be about 3 or 4 times greater if we would discard this value. If we would use exactly the same amount as the current practice on the 14 pen, the value would be much greater than this. We expect improved health with this and much less excretion with this situation. We calculate this, and if you want more detail, is in the paper indeed. But because of time, I will stop here and just leave you with the main message that we think, we are convinced nutritional grouping is a good way to promote improved feed efficiency in dairy herds. And with that, I just would like to acknowledge the funding source for this last project of the Dairy Brain from the Food and Agriculture Cyber Informatics and Tools initiative from the USDA National Institute of Food and Agriculture. Thank you very much for your attention.